Okay, these four rules for determining the precision of a measurement, which really is saying, hey, how many sig figs are in the quantity I'm presented with, can be a little bit confusing. So I think a few examples might be helpful. So let's apply these rules to these various quantities below. Number one, 123 kilograms. So the first guy here, I'll just go 1, 2, 3, 4. So number one. All right. I'll underline all the significant ones. 1, 2, 3. Okay, there's 3. So three significant figures. Okay, do you see the rule? That guy, they were all non-zero, so they were all significant. Number 2, let's see. The 2 is significant, the 5 is significant. What about this 0? It's not a captured 0, it's not a leading 0, it's a trailing 0, but it's not after a decimal point. So this guy is not significant. So that is 2 sig figs. You know what I'm going to do? I'm going to put a red line under things that aren't significant. So not significant. So red means not a significant figure, and a blue line means a significant figure. All right, the next one, number 3. I've got 0.00306 grams. Okay, let's start with the non-zeros. 3 and 6 are significant because they're non-zeros. What about the 0 between them? That is a captured 0, so that is significant. What about these leading zeros? Leading zeros are never significant, because if I converted this from kilograms into milligrams, I believe if I'm thinking of this correctly, that's the same thing as 306 milligrams. Let's see, 1, 2, 3, yeah, I think so. Doesn't matter. I lied. It's not 306 milligrams. It's 3.06 milligrams. But my point, I'm still going to make it because those leading zeros just disappeared. Okay, so this one is 3 significant figures. Number 4, the non-zero 1 is significant because it's not a 0. What about these trailing zeros? The 0, 0, 0, those are not significant. So remember, trailing zeros are not significant unless they come after the decimal point. These guys basically are just placeholders. They're there to make this 1 turn into 1,000, because if you didn't have the zeros, this is how we do it in our number system, is we add zeros as placeholders. So those are not significant. So this is only 1 significant figure. So let's think that, what does that mean? That means this is actually a pretty darn imprecise measurement. This could be anything from just over 500 seconds to, or I think just 500 seconds to just under 1,500 seconds. So this is incredibly imprecise. There is a 1,000 second uncertainty in a time of 1,000 seconds in this particular measurement. So that is not a precise quantity at all. Number 5, and then we'll go 6, 7, 8, 9. Number 5, 20 centimeters. The 2 is significant because it's not 0. And the red one is not significant because it's a trailing 0, but there's no decimal place. So that's a placeholder, meaning it's just there so that nobody thinks that 2 is 2. That 2 really represents 20 centimeters. Okay, number 6, non-zeros are significant. Okay, what about the 0 captured between 2 significant figures? That is significant. Okay, what about these last three? They are not. Whoops, sorry, I used the wrong color. Sorry about that. That guy, the trailing zero is significant. The captured zero is significant. These trailing zeros are not significant. Those are placeholders. So this is 3 significant figures. Okay, what about number 7? The non-zero always significant. What about these trailing zeros? They come after the decimal place, meaning they're not there to make that 3 a 3. It's already a 3. They're there because this guy was certain. 3 is certain. That first zero is certain. Certain estimate. So they were there because they're there solely because of the measurement. They're not placeholders. So that is 4 significant figures. What about number 8? Let's see, non-zero is always significant. So the 2, 5, 7, significant. What about this first zero? That's a captured zero. Zero between sig figs. So that is significant. And the last one's significant too because it comes after the decimal place. So just one more time. If going back, you can rethink how this measurement was taken. The 2 is certain. The 5 is certain. The first zero is certain. The 7 is certain. And then this last one is the reasonable estimate. And that's why they stopped. That's why there isn't another zero. That would be a guess. All right. Now what about scientific notation? Scientific notation is the easiest of them all because everything in the I'm going to call it the coefficient, I guess, but it actually has a real name that's kind of cool, is everything in the first part is significant. Because you know what this is actually called? I looked it up. This part of the scientific notation is called the significand. Isn't that amazing? Because everything in it is considered to be significant. All right, those are some examples. Hope it helped.